Okay, we're going to take a look at number 20 out of 9.3. This says referring to columns 1 and 2 of dataset 24 word counts, and use a 0.05 significance level to test the claim that among couples, males speak fewer words than females. So we saw a similar problem to this back in 9.2, which involved independent samples. But this one, when we look at our claim here, what's different about this one is that we're talking about couples here. So the first male in column 1 and the first female in column 2, they are together as a couple, and the same thing would be true for the second, the third, everyone in here. So this is a case of paired data here. So since they go ahead and talk about males first, that's going to represent our first sample. Females then is going to represent our second sample. So our claim here, if we're going to have men speaking fewer words than women, the first number minus the second number, that's going to be something that is less than 0. And if you have trouble seeing that, so we have the number of words spoken by a male in a day minus the number of words spoken by their female partner in a day. If the male is less, so let's just substitute some numbers in here that fit that description. That would be -2, and -2 is less than 0. So that's something you can do to kind of help yourself out to make sure that you're formulating the claim correctly. And the opposite of that is the mean of the differences is greater than or equal to 0. So that gives us enough information to go ahead, formulate our hypothesis statement. So mu sub d and 0 are what go in there. What goes between them in the null is equal because it's always equal in the null. And the strict inequality, that's in the alternate, that's going to be the less than. And now when we do the R and S for the claim, that is represented by the alternate. So we'll note the S there. So take a look at this. This is a left tail test. Our significance level, that's alpha, that's 0.05. And because we're working with raw data here, there's no sample statistics to go ahead and list out. So that's why we're not doing that here. So now we can go ahead, use our significance level to write our rule of rejection. And that's reject the null hypothesis if the p-value is less than or equal to whatever our significance level was. That's 0.05. So again, that is the terms in which we're writing our rule of rejection. Now our test statistic is going to be t. If you didn't know that, that's fine. StatDisk will tell us what distribution we're using, which will let us know which letter or symbol we should use for our test statistic. And again, I'm lining up my p-value directly underneath the p-value and the 0.05 above it in the rule of rejection. So now I'm going to head on over to StatDisk. We're going to open up dataset 24. And we're using the first 2 columns. And what we can see here is we've got 56 of each. So one of the requirements of paired data is that our sample sizes for both groups are the same. So analysis, hypothesis testing, mean, matched pairs. And ours is the mean of differences less than 0. Our significance level is 0.05, and we're in luck that our first sample is already column 1. Our second sample is already column 2, exactly what we wanted them to be. So we're ready to hit evaluate and plot. And what we do see is we do see that our blue does not fall in the tail cut off by the red there. And when we go ahead and take this back over there, so let's head on over back here. Let's go ahead and put that in there. Oh, let's make this usable. There we go. So our value for t here, let's see, is it going to, it's going to be giving me trouble. So let's go ahead and try this because that usually works. There we go. So our test statistic here is negative 1.560. Our corresponding p-value is 0.0622. And that is not less than or equal to 0.05. So we do not reject the null hypothesis. We fail to reject the null hypothesis. And when we fail to reject the null hypothesis, we don't have the evidence. We have insufficient evidence. And I'm using that to stay consistent with how it's phrased in my stat lab. So we have insufficient evidence to, and now the second part of our conclusion is based on where the claim is represented. It's the alternate. That's why we mark the S, and S is for support. The claim that, and then now we just go ahead, copy paste the claim among couples, males speak fewer words than females. And yep, I left out in a day. There, now I added it back. So we put the conclusion with respect to the claim together in 3 parts. Let's go back and read it all the way through. We have insufficient evidence to support the claim that among couples, males speak fewer words than females in a day. So we don't have the evidence to say that men are speaking less than their female partners here. We were unable to reject the null hypothesis. And again, the null hypothesis is that that difference is equal to 0, that there's no difference. So we weren't able to throw away the idea that there was no difference in the number of words spoken by male and female couples in a day. So the last thing they want us to do here in part G is identify the information on the sample. And that information is given to us right here. So there was 56 couples, N is 56. The mean of the differences, that is D bar, D with the bar over the top of that. And that is negative 1,867.1. And the standard deviation of the differences was 8955.2. And if you're wondering why I went out 1 decimal place, our original data, which was number of words spoken in the day, that was an integer, and we go 1 decimal place beyond the original data. So our original data was going out to the 1s digit. That means for confidence intervals, for any summary statistics that we do, we would round them off to 1 decimal place. Speaking of confidence intervals, so if we were to write out this confidence interval, mu sub d That's negative 3869.2 to 134. 0.980, we're going to round up, so 135.0. So what you need to notice about this confidence interval when it comes to interpreting it is this confidence interval contains 0. It contains the, and since 0 is in it, it is plausible that the mean difference is 0. So this is plausible. It doesn't mean that it's true, but we can't rule it out. And that's what we did in the hypothesis test when we said fail to reject the null hypothesis. That's when we, this is saying we can't rule out mu sub d equaling 0. Why? Because our sample result was a plausible value. That was a reasonable value to get by chance. And if you're looking at this and wondering, and this is a big reason of why we need to follow through this process, is when you look at the sample mean difference, or the difference, the mean of the differences in the sample there, they differ by just shy of 1,900 words. That may seem like a lot, but what is a lot, what puts distance into perspective in terms of close or not close, is the standard deviation. And our standard deviation is almost 9,000 words a day. So that's something that goes ahead and puts this difference into perspective. Now, when we're comparing groups, we would have to do the standard deviation that's based off of a sample size of 56 there. But even, if we divide by the square root of 56, that's dividing by about 7.5. Our standard deviation is still going to be, our standard error here is still going to be well over 1,000. So that's why we're seeing here a confidence interval that does span into the positive. So again, this confidence interval is centered at that number. So this, so this confidence interval is negative 1867.1 plus or minus the margin of error. And because the standard deviation is large enough, well, again, that is our standard deviation here. When we multiply this by the critical value to give us our margin of error, that's large enough to take us into positive territory. So that's why that's why I did want to go ahead and talk about this. And this is why we don't make decisions based on our point estimates. Yes, that's not far from 2,000 words a day difference. That may seem like a lot, but it's standard deviation that gives us perspective on how close or how far something actually is.